Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a nice problem with complex numbers. Now some of you will probably recognize this problem from June 12th because on that date I made a video on this problem, and this is what I got. How embarrassing, right? Well, I messed up big time. And thank you for all the beautiful comments that kind of gave me a heads up, and I kind of removed that video because that was a huge embarrassment anyways. And I wanted to redo of this problem. As you can see, I'm thinking that this will be completing the square. Anyways, you get the idea, and I just made a huge mistake. Now, we're going to correct it today. Let's go back to the problem and do it right. So we have this absolute value of z plus 2 times z times the conjugate of z, the complex conjugate of z equals 36. And we're going to be solving for z values. Now, how do we solve for z values? We're going to go ahead and use some identities that are super duper important with complex numbers. So let's go ahead and see how we can handle this. First of all, notice that this product is very special. What happens if you multiply a complex number by its conjugate? You do get the absolute value of that number squared. Why? Because z equals a plus bi. By the way, this is also the name of this channel, right? And z bar is just going to be a minus bi. If you multiply these guys together from difference of two squares, that actually turns into a sum of two squares. And this just happens to be the absolute value of z squared, because absolute value of z is equal to the square root of a squared plus b squared. Great. This is a really nice identity, and it's going to allow us to solve this problem. But if you remember the thumbnail, it says, can you solve this problem? So we're going to use u, not you, but the letter u, because we are going to substitute. All right, ready? So let's go ahead and set absolute value of z equal to u. And then we get the following. Let's go ahead and clean this area. Set absolute value of z equal to u. And remember that this is the absolute value of z squared, therefore u squared. So you get u plus 2u squared. I should say 2u if it's your birthday. Happy birthday to you. Anyways, this is 2u squared, so it's kind of like more than 2u. Great. So how do we solve this problem correctly, right? This time, or hopefully. We can kind of put the 2u squared first, and then plus u equals 36. And then let's put everything on the same side. I don't know why I did that extra step. Now, this is a quadratic equation. You don't need to complete the square because 2u squared is the quadratic term. Well, we can use the quadratic formula, pretty easy to do. And guess what? This is going to have nice solutions. Maybe a nice solution. Who knows? Let's find out. Negative b plus minus the square root of b squared, which is 1, minus 4ac, which is 4 times 2 times negative 36. I'm first going to go ahead and plug everything in. And at the bottom, we have 2a, which is 4. Now, notice that we have a double negative here. That's going to turn into a positive. 4 times 2 is 8. 8 times 36 is 288. Plus 1 is 289. So u are negative 1 plus minus the square root of 289 divided by 4. But wait a minute. You should memorize your squares, right? At least 1 through 25. And I did. Anyways, so from here we get negative 1 plus minus 17, because 17 squared is 289. And this gives us two solutions. You give us two solutions. Thank you for that. Now we get negative 1 plus 17 over 4. That's going to be 4. Or u equals negative 1 minus 17 over 4. That's going to be negative 18 over 4, or negative 9 halves. Great, but not so great. Because remember, u is absolute value of z. What does that matter? Or does that? Well, the absolute value cannot be negative because it is the absolute value. So we have to go with 4. We're going to forget about this solution. You see, sometimes you get a solution, but it doesn't satisfy the original problem. Those are usually called extraneous solutions. All right, so absolute value of z equals 4 should be the answer, or at least it brings us closer to the answer. Like, so what? did we find z? Well, if you were working in the real world, you could probably say something like this. Hey, if absolute value of z is equal to 4, then z is 4 or negative 4. That's true partially, because yes, these are solutions, but these are not the only solutions, because we're not in the real world. Come on. This channel is all about complex numbers, and it's called what? A plus bi, right? So we got to be more careful, and we have to find all solutions. How do we find all the solutions? By thinking about the meaning of absolute value. What do I mean by that? Well, in the real world, absolute value basically means the distance, right? So you have 0, and then you basically have two numbers whose distance from 0 equals 4. Those numbers are 4 and negative 4. So there are two solutions in the real world. But in the complex world, you kind of have to think about it this way. You have to think in two dimensions, because you are looking at what's called the argand plane. A lot of people are pronouncing it, or I guess spelling it very differently. So I'm going to go ahead and write how it's spelled. This is how you spell it, right? Argand plane. I don't know if there's a different pronunciation, and you don't really have to worry about it. Anyways, real and imaginary. Now you have to think about it this way. Which numbers in the complex plane are 4 units away from 0? Yes, 4 and negative 4 are, but 4i is also going to work, as well as negative 4i. And those are not the only ones either, because you can basically draw, is that a circle that goes through them? Any point on this circle should be 4 units away from 0. And that's actually called the modulus, or the absolute value of that complex number. So you kind of have to think in two dimensions, and that gives you, instead of 2 points on the number line, gives you infinitely many points on a circle. Make sense? Okay, how do we get the circle though? Well, from here we have to work correctly. And let's rewrite it. Absolute value of z equals 4. Wait a minute, isn't z a plus bi? Let's just go ahead and assume, for the sake of this problem, that z can be written as x plus yi. It's not the name of this channel, but it's still something being used commonly. So we have the absolute value of x plus yi, but by definition, the absolute value of x plus yi is the square root of x squared plus y squared. And then if you square both sides, you get x squared plus y squared equals 16. This is the equation of a circle at 0, 0 with radius 4, right? And let's go ahead and take a look at the picture. Did I include a picture? Yes, I did. Awesome. So here's the center, here's the radius, pick any point, and it'll be 4 units away from 0. And this brings us to the end of this video. But thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.